of you are having holidays right now, correct? Krishna Priya, Arslan, and Yusuf.
Yes, sir.
Yes.
Yes, sir.
Okay, and I think Krishna Priya, your holidays are only till 27th. You said something like that.
Yes, sir.
So, and is there any holiday for the 31st or the 1st of January?
No, sir, nothing for New Year.
Nothing for New Year. Okay. So, will
Sir,
yeah, Yusuf, tell me.
I will be having winter coachings.
You have winter coachings from school,
Yeah, from 27.
27th. Like you have to online or is it's all offline?
It's offline.
So at what time?
It's 8 to 12.
8 to 12. This is KSA, right?
Yes, sir.
Okay. And what about evenings? Are you guys free on Tuesday and Thursday? Timing is this time only 4 to 5:30 KSA.
Yes, sir.
Yusuf, what about you?
I will be having biology classes.
You will be having biology classes at this time. Okay. Fine, ठीक है, but so I will have at least tomorrow we can have a class. Tomorrow, कल तो हम there is a I will start revision with haloalkene and halorine. So that's something we have already done, no? Haloalkene and halorine. Okay, so we'll start from there. And tomorrow I will schedule a class for you guys.
At what time, sir? Same, 4.
And no. Tomorrow, so you have the regular class will be there, no? I mean, this class will be there as it is. There will be one extra class for you guys. Okay.
When is that going to be?
Sorry,
When is that going to be, sir?
time.
Yeah.
Just a second. Right now, 12 noon is for 12 noon IST. 12 noon IST is a revision class. अच्छा नहीं, कल नहीं लेते ना आप, but how will you complete then? You can't be attending three classes in a day, na? And that too of chemistry. Or is it fine for you guys? Tell me. 3 classes of chemistry. There will be one revision class, there will be one extra class, and there will be one regular class. Regular class timing is 4 p.m. to this current timing, 4 p.m. to 5:30. This is KSA. Revision is morning, that is, I think it's 9:30, no? 9:30 a.m. KSA, not IST. This is for your convenience, KSA.
And when will you have the extra class, sir? What time?
I will decide the time first. You guys tell me. You will be attending 3 classes for chemistry. That's fine for you with you. Will you be
If
attending or not? Nana? Yusuf
I
Arslan.
I am
Sir,
currently traveling, so I might not have internet all the time.
Where are you, Krishnapriya?
At present, I am in Riyadh, sir, but tomorrow I have to check out in the morning.
You're going somewhere.
Yeah.
Okay.
sir, this will be for tomorrow.
Yep. Tomorrow.
Okay.
Arslan, what about you?
So tomorrow, yeah.
Yeah, tomorrow.
Yes, sir.
Okay, fine. So this is 12 noon. This is 6:30. Between 12. So tomorrow I will be so hectic with me. 9:30 से आपकी क्लास रहेगी 9:30, 10:30, 11. So we can start with 11:30 a.m. And then again in 4 p.m. Fine.
Okay, sir.
Yes, Krishna, you're saying something?
I most probably won't be able to attend the extra class, sir.
You won't be able to attend the extra class.
Yes.
Then what about from Tuesday? Monday will be a holiday. So no classes are on Monday. What about Tuesday? Tuesday you will have internet connection all the time.
Yes, sir. Tuesday I will have all the time.
Fine. Then we can schedule it on Tuesday. Tuesday you will be have Tuesday. This is okay. Tuesday. Tuesday, 9:30 a.m. You will have revision. Revision will be now daily. Okay. It is starting on Sunday. Monday is a holiday. Then Tuesday you will have revision. Wednesday you will be having revision. Krishna Priya, and are you having pre-board or something, or is it regular classes in your school? And do you have to
Regular
attend this?
classes, sir.
You have to attend this school. You cannot miss it.
Yeah, I have to attend school.
Then how will we complete the syllabus?
I don't know, sir. But I am free after 2 o'clock. After that, it's fine. Any day.
2 p.m. Why? Which clock?
Saudi.
Okay, say
Yeah.
this will be 4:30 in India.
After
4:30.
that, anytime, sir. Till 9, 10, it's fine.
But 4:30 I am not free. 4:30 I can be free, but like 5 o'clock only I have Maghrib prayers. So I will have to like mm,
Anytime after 4:30 is fine, sir.
and what are your holidays like Saturday, Sunday, Friday? What days is
Friday
your
and
holiday?
Saturday.
Friday and Saturday. Saturday आपकी तो जनरल क्लासेस होती हैं. हम्म. ठीक है, I will keep this in mind. ट्यूसडे यू हैव टू नहीं ट्यूसडे तो 26 है ठीक है ट्यूसडे एटलीस्ट एक एक्स्ट्रा क्लास कम से कम हो जाएगी फिर एंड फाइन सो योर 2 p.m. KSA that is 4:30 p.m. IST ठीक है I will keep this in mind. However, it is generally not possible for me 4:30 p.m. because I take a class which ends at 4:30 p.m. IST and that's an offline class. Just after that an online class and then Maghrib and then again I have to take class. May become hectic for me. I will see if it's possible. Then I will be doing this class 2 p.m. to 4:30. Chali fair. Now, how much was done in your class? We were doing second method of preparation from nitriles using Grignard reagent, and this is B part. Achha. Method of preparation of ketones only. Aldehyde only is done. Ketones only. Yep. Ketone only is also done. And we also started method of preparation of aldehyde and ketones, both from alcohols by oxidation. PDC. चलिए ठीक है. From alcohols only, there is one more technique that we can use. ठीक है. There is also one more technique. I'm just including that in this notes only, right here, B part. This is also we have seen by catalytic dehydrogenation. So we are looking at the methods of preparation of aldehyde and ketones both. So if you use 1 degree alcohol, that is RCH2OH, and you treat this in hot copper, we have seen this reaction in the alcohol chapter also. It is going to give you aldehyde, RCHO, that is aldehyde. 1 degree alcohol gives aldehyde, and 2 degree alcohol, that is RCHOH, and you have R dash, the presence of the same reagent, you will get R, C double bond O, and R dash. Now, a note is what happens if we do the same reaction with 3-degree alcohol? So 3-degree alcohol gives alkene. Gives alkene. Then you have Ag can also be used. So in the reaction, if they don't give copper, but they give Ag and 573 Kelvin or heat, then also the same reaction will occur. But usually we don't use silver because silver is quite expensive. Write this down, raise your hand once you're done, and then we will move on to next starting material. Waiting for Yusuf, Arslan, and Mir. Waiting for Yusuf and Mir. Mir, just waiting for you now. Mir, if you're done. Now, starting with today's, the first we have seen from alcohol. Let's write another from hydrocarbons. From hydrocarbons, first method of preparation is hydration of alkynes. Hydration of alkynes. Now, this is a reaction which you must have learned in the 11th standard, but you must have also forgot about it. And maybe बहुत सारे लोगों ने शायद नहीं भी पढ़ा हो, ठीक है? So what happens in hydration of alkene is we have R, which has carbon triple bond carbon, and then you have R dash. Okay, let's suppose this is R or R dash, whatever it is. Then what happens when you add water to it? This water is added in the presence of. So let me do one thing. Let me add water here, and it is done in the presence of H2SO4 and HgSO4. Okay. Now here when you have hydrogen and then you have OH, one of the carbon gets hydrogen, the other carbon gets OH. So you have R carbon, triple bond is broken, it is converted to double bond, and then you have here hydrogen. One of the carbon, it gets hydrogen, and the other carbon gets OH. The R group is as it is here. Now, if you look at this carbon atom, this is a important carbon atom because this carbon atom, it is having a double bond, and it is also having a OH group. So for double bond, we say it is ene, and for OH, we say it is ol. So it is also known as enol. Now, when you have enols, then in this case, a special reaction occurs because the hydrogen atom, it is connected with oxygen, which is more electronegative. It gains a highly delta positive charge. Now, this delta positive charge on hydrogen atom, it is also near to the pi bond. Now, what happens? This pi bond, it attacks on the hydrogen because pi bond is electron rich, negatively charged. So this electron, it attacks on the hydrogen, and a proton transfer takes place, which is known as tautomerism. And when you get R, C, this hydrogen, this carbon atom, it already had a hydrogen, it is getting one more hydrogen, so it becomes CH2. Then you have C double bond O, because as soon as this pi bond attacks on the hydrogen atom, this hydrogen atom leaves its electron towards this CO bond, and we get CH2 and R. So you can see that we are getting what, aldehyde or ketone? Depends, because if this R, it is a carbon atom, then it will be ketone. But if this R is a hydrogen, then this will be aldehyde. Okay. Now I'm giving you specific reactions, but before that, general क्या हो रहा है आपके पास? R CH double bond C OH. and you get RCH2. So attached here, this goes here, single bond C double bond O and R. This is known as the enol form, और जब यहाँ पे C double bond O बन जाता है, you have the keto form. ठीक, and this is known as tautomerism. This is exactly what's happening when we add water to alkynes. Now, let us see some reactions. Let us suppose we have CH3 कार्बन. अच्छा, पहले तो हम लोग बिल्कुल सिंपल देख लेते हैं. आपके पास मान लीजिए आपके पास क्या है, H C triple bond CH. Then when you add water, now since both of the carbon atoms are same, they are symmetrical alkyne, one of the carbon will get hydrogen. So let us suppose one carbon gets hydrogen, CH2 double bond CH, and then we have OH like this. The same keto-enol tautomerism will take place, and you will get what? CH3 CHO. So when you have ethyne, you are getting an aldehyde. Next case is, let us suppose you have CH, then you have triple bond carbon and a CH3. Now whenever there is an addition reaction on a pi bond, then we follow the Markovnikov's rule. The negative part of the reactant or the reagent goes to that carbon which has less hydrogen. So the reaction occurs something like this. This carbon atom will get the OH because it has 0 hydrogens. This carbon atom will get the carbon because it has what? It has 1 hydrogen atom. And so the carbon atom which is having less hydrogen will get the negative part. Now here CH2 double bond, because 1 pi bond is broken, and you get OH like this, and the CH3 is as it is here. So now again this carbon atom attacks here, this hydrogen goes here, and you get CH3 bonded to carbon double bond O, and then you have CH3. Okay, now let's see if you have, now this is propane 2-1. Propane 2-1. This is what? Ketone. This is the only aldehyde. ये क्या हो गया आपके पास? Through carbon atom, so ये हो गया acetaldehyde, or you can also say it is what? Ethanol. Let us suppose if you have CH3 on both the sides, CH3 carbon triple bond carbon, and then you have again CH3. In the presence of H2O, one carbon will get the OH and one carbon will get the hydrogen. So you will say CH3 CH double bond C CH3, and this carbon atom gets the OH. Same thing happens, tautomerism, and you get what? CH3 CH2 C double bond O and CH3. Okay. Now if you want to have a trick type of thing, then the carbon atom with less hydrogen, you can see this one, carbon atom with less hydrogen gets the double bond O directly. If both the carbon atoms are having same number of hydrogen, just for example 1 1, तो जब आपके पास दोनों में एक एक हाइड्रोजन है, then you will get what? You will get an aldehyde. किसी में भी आप क्या लगा दीजिए? डबल बॉन्ड O लगा दीजिए. There is only one case. Now here you can see there are 0 hydrogens. Then here also you can attach the C double bond O to any one of the carbon atoms. Please write this down. Please give me a second. Copy this down. Now all of these are happening in the presence of Hg2 plus and H2SO4. ठीक है, ये ध्यान रखिएगा. I have not written this down, but it is just expected. You can just write like this. The carbon containing less number of hydrogens. The carbon containing less number of hydrogens gets double bond O, and the other carbon Okay, I hope everyone is done writing. Now there are few points regarding this hydration of alkyne. ये तो आप लोगों को ये this is something that you have to just remember ना, carbon containing less hydrogen gets the double bond O in order to make the product. Something can be asked is formaldehyde cannot be prepared from this method. Formaldehyde cannot be prepared by this method. ठीक है. Why? Because formaldehyde में एक carbon atom होता है and alkyne it has only the least number of carbon atom and an alkyne can have is 2. ठीक है. Formaldehyde cannot be prepared by this method as alkyne contains at least 2 carbon atoms. Now, next is aldehydes. Rather, if you want to prepare aldehyde, then there is only one aldehyde that can be prepared, only acetaldehyde can be prepared by this method and no other aldehyde. Next is by ozonolysis of alkene. Now, this is another important method of preparation. ठीक है. See here. Alkene will have carbon double bond O, sorry, carbon double bond carbon, and there will be 2 groups on each carbon atom. In the first step, we have ozone. Second step, we add zinc in the presence of water. Now, what happens here is that this is how you're going to remember it. You break the double bond like this. Okay? So when you break the double bond, you will have C with the 2 groups as it is, and the double bond, half double bond is broken like this. Double bond is this ho jayega. Now this carbon atom will get oxygen, this carbon atom will also get oxygen. Like this. Plus you have O, double bond carbon, and the 2 groups. Okay? How you are going to make the products? Please see. You have CH2 double bond, CH2. First we react with ozone. Second we react with zinc and H2O. I'm only showing you guys how to make the product. What is happening in the reaction? Like first ozone is added, then what happens, and then zinc is added, then what happens? I'm not showing you that right now. Just showing you guys how to make the products. So here what will happen? You will break this double bonds like this. One oxygen here, the other oxygen here. So you will have CH2 double bond O plus O double bond CH2. Now you need to identify what type of compound is this. So there is a carbon atom, it is having a double bond and 2 hydrogens. So we have a CHO group, and this is also same thing, and it has only 1 carbon atom. This is methanol. It is also very important to identify it. It looks very weird, CH2 double bond O, but once you see, okay, fine, the carbon atom which is having a double bond, it's the carbon atom which is having 2 hydrogens only. Similarly, you have, let us suppose, CH3, CH, double bond, CH, and CH3. Here also the same thing, you'll break the double bond and oxygen. The same reagent is used. You will have CH3, CH double bond O, plus oxygen double bond CH, and then you have CH3. Now both of these are also same thing. Now if you look at this carbon atom, like what is this compound? It is CH3 that is connected to a carbon atom. This carbon atom has a double bond O and it has a hydrogen atom. Now you can see that, okay, fine, this is a what? It is a aldehyde. What type of aldehyde? What will be the name? This, both of these compounds are seen, and this is what says ethanol. Two carbon atoms with a aldehyde group. Next, you can have something like this. As you can see, till now we have only made aldehydes. If we want a ketone, then ketone can be prepared like this: CH3, CH, double bond, carbon, CH3, and let's suppose the CH3 is here. Then we do the same thing, break it, double bond O, double bond O. You'll have CH3, CHO, okay? Plus you will have oxygen, double bond, carbon, which is having a CH3 group here and a CH3 group here. Now this is methanol. Sorry, this is ethanol because there are two carbon atoms. Ethanol. If you look at this compound, it is three carbon atoms and there is a ketonic group. So it is what? Three carbon propane. Ketonic group will be on. So it is propane 2 on. Okay. Similarly, see, if you have a cyclic compound like this, and you have a double bond, and then you have carbon atom, and this carbon atom has a CH3, this carbon atom has a CH3. Then here, what's going to happen? We'll have the same ozone plus H2, and we'll break it like this: oxygen, oxygen. This will get double bond O, plus you will get CH3, carbon double bond O, and then CH3. Okay, chaliye, please copy these reactions. Then I will give you guys a few reactions. Okay, copy this down and come back. Okay. So guys, do some questions. Huh? There are a few questions in the NCERT. Just get the NCERT for you guys. Just give me a second, guys. Arrange, predict the products. Hmm. Let me give you some questions. Do these two questions. Send the answers on my WhatsApp. Once you're done, send the answers on my WhatsApp. Okay. Mm, okay, Krishna Priya, you can show it. If you're done, you can show it on your camera. If you can turn the camera on. Yes, Krishna Priya.
Hold on, sir. I'm trying over here. Wait.
Fine. What about you, Arslan?
Yes, sir, I'm doing.
Once you're done, you will send the answer. No? Yes, Arslan, are you done?
No, sir.
Why? Why you guys are taking so much time? You just need to like this, and then oh. Yes, Arsalan, what's happening?
Yes, it's a bit confused on the first one. So we'll get on ozone analysis, we should get CH3, CHO, and
No. It's not. आपको ये करना है. फिर यहाँ ऑक्सीजन, यहाँ ऑक्सीजन. You do the process ना. You don't have to think like what should be the product. उसके बारे में आपको सोचना ही नहीं है. You will make the same thing as it is. इतना part आप as it is बनाइएगा. Then you will write double bond O. इतना part आप अलग से बनाइएगा plus, and then you will write double bond O. That's it. आपको प्रोडक्ट याद ही ना करना, वो प्रोसेस याद करना. सारे में सेम प्रोसेस है. To try to identify now what we did here. What did we do? तोड़ा इसको, ऑक्सीजन और ऑक्सीजन लगाया, है ना. यहाँ पे भी
yes,
देखिए CH3. ठीक है, तो उस प्रोसेस पे कीजिए प्लीज, है ना. एंड डू इट क्विकली, डोंट थिंक टू मच. ठीक है, एंड सेंड इट टू मी.
okay,
उसमें
sir.
जो मिस्टेक होगा उससे समझ में आएगा ना कि आप मतलब गलती कहाँ कर रहे हैं. इफ यू आर गोइंग ट्राइंग टू think about the product too much, then it will be obviously wrong.
Okay, sir, भेज रहा हूँ.
हाँ, send it to me. What happened, Krishna Priya?
It's not working, sir.
It's not working. अच्छा ठीक है, no problem.
I get disconnected whenever I try to turn it on.
अच्छा, no problem. It's not looking at your answer. It's okay. बस, that's it, अरसलान. ठीक है.
Yes, sir.
It's correct. इतना कुछ क्या लगा, कुछ टाइम लगा. अब यहाँ पे, अब once you have made this ना, ये बहुत weird looking product जो आपने बनाया है, इसको आप समझिए कि कैसे होगा सही. ठीक है ना. आफ्टर यू हैव मेड द प्रोडक्ट, अब उसके बाद so you made like this ना, CH3, CH2, and then C double bond O, और फिर CH3. करेक्ट?
Yes, sir.
ये सुनो, ये बनाया ना आपने, ठीक है? अब यहाँ काउंट कीजिए, हाउ मेनी कार्बन एटम्स आर देयर?
Sir, 4.
एंड वेयर इज द डबल बॉन्ड? कौन से कार्बन एटम पे डबल बॉन्ड है?
Yes, sir.
कौन से कार्बन एटम में डबल बॉन्ड है? विच
Sir,
कार्बन एटम?
third. Sir, third
सेकंड
one.
बोलेंगे ना, सेकंड बोलेंगे नहीं,
Hmm.
सेकंड कार्बन एटम ना, तो कितना हो जाएगा? इसको बोलेंगे क्या? ब्यूटेन 2 on, मेक सेंस? और CH2
Yes.
डबल बॉन्ड O के लिए तो हमने बता ही दिया क्या करना है आपको। दिस इज मीथेनॉल, ठीक है? सिमिलरली हियर आल्सो यू हैव डू द सेम थिंग, ऑक्सीजन ऑक्सीजन, CH3, ये तो बहुत आसानी से मिल जाएगा आपको, CHO है ना, एक कार्बन एक हाइड्रोजन है और एक ऑक्सीजन लग गया, प्लस दिस इज द सेम थिंग दैट वी हैव सीन प्रीवियसली, C डबल बॉन्ड O, इधर CH3 और इधर भी CH3, we are having 3 carbon atoms, so it will be propane and there will be 2 on. Right, next, physical properties. Physical properties. And write the first point. Aldehyde and ketones are miscible in water as they can form hydrogen bond with water. Carbon double bond O, and then you will have delta positive. Here we have the lone pair electrons. Okay, like this. So this is the hydrogen bond. Okay. Also one more point. Solubility decreases on increase in number of carbon atoms in alkyl group. Now this is the same thing that as we saw in the cases of alcohol and ether also. No? The part, if you are going to increase the alkyl group, then the alkyl groups are hydrophobic. They don't dissolve in water. The oxygen part is the only part which is enabling the dissolution in water. If you're going to increase the hydrophobic part that is not very soluble in water, the solubility will also decrease. Now regarding boiling points, right? Boiling point of aldehyde and ketones. Ketones are higher than non-polar hydrocarbons and weakly polar ethers, as aldehydes and ketones are polar molecules. Is that right? Due to absence of hydrogen bond in aldehyde and ketones, their boiling points are lower than alcohols. Now, see here, guys. Let's suppose we have these molecules arrange the following compounds in the increasing order of their boiling points. Now, this compound, whenever you get some questions like this, now you'll first of all classify the compound. This compound, it is aldehyde. That means it is polar. Okay. This compound, it is alcohol. This is hydrogen bond. This compound, it is ether. This is weakly polar. And this compound, it is alkane. And that is why it is going to be non-polar. ठीक है, तो सबसे पहले आप लोग को इस तरह की आइडेंटिफिकेशन आनी चाहिए, that aldehyde, alcohol, ethers and alkane. Now from here only we can classify which is going to have the highest boiling point. See, because of the presence of hydrogen bond, alcohol, let me give it some numbers, A, B, C and D. Okay. So the B will have the highest boiling point. Then we have polar, that is aldehyde. And then we have the weakly polar, that is C. And then we have the non-polar, that is D. Now, after that, if we have one more aldehyde, then you will compare the number of carbon atoms. Okay. If you have alcohol, then also we'll compare the number of carbon atoms. And if those same class of compounds which are both having hydrogen bond or both are polar, then we compare the number of carbon atoms. If the carbon atoms are also same, then we compare the branching. Write this down. And after this, you will write chemical properties. Aslan and Krishna Priya, done?
Yes, sir.
In chemical properties, the first type of reaction that we are going to see are known as nucleophilic addition reaction. In nucleophilic addition reaction, a general mechanism is something like this. We have carbonyl compound, aldehyde or ketone. It can be anything. The carbon atom that is connected with double bond oxygen, it is having delta positive charge. There comes a nucleophile. As soon as this nucleophile, it attacks on the carbon atom, this pi bond of carbon oxygen, it breaks and you will get carbon, two single bonds, O negative, nucleophile. After addition of H plus, and you get OH like this. So this is a general mechanism. Okay. There is a change of hybridization also. This is sp2 carbon atom. It is sp3, and this is also sp3 carbon atom. ठीक है, this is a general mechanism. Nucleophilic for nucleophilic addition reaction. Now, when we compare the reactivity, एक सवाल आता है generally, reactivity of aldehyde and ketones towards these type of reaction. ठीक है, तो please write first of all that reactivity of aldehyde versus ketone towards what? Towards nucleophilic addition reaction. ठीक है, ध्यान दीजिए जरा. Now, if the nucleophile can attack easily, then the reaction will be faster. The main criteria is that only, na? If nucleophile can attack easily, then the reaction will be faster. ठीक है. Now, what are the factors that are not going to make it easy for nucleophiles to react? There are two conditions. एक होता है इलेक्ट्रॉनिक कंडीशन, एक होता है स्टेरिक कंडीशन. ठीक है, ध्यान से देखते हैं. केस ऑफ एल्डिहाइड एंड कीटोन दोनों को देखते हैं. You have aldehyde, you have ketone. ठीक है. See, now please see here. Let's suppose we have nucleophile. Now, if we want to talk only about sterics, ठीक है, sterics का मतलब होता है that when the nucleophile is going to attack on any carbon atom, there will be some groups attached on the carbon atom, and those carbon atom will those groups which are attached on the carbon atom, they will hinder the attack of nucleophile. वो nucleophile को hinder करेंगे. So you can see that we have larger groups in the ketone case. In the aldehyde case, we have only a hydrogen atom which is not very bulky. Since due to the presence of, we can say due to the presence of bulky alkyl groups, the attack of nucleophile will not be feasible. That's the first thing. Now, when we talk about the electronics, then let us see. In electronics, what is enabling the nucleophile to attack on the carbon atom? It is the delta positive charge that the carbon atom has in both the aldehyde and ketone because of the presence of double bond. Since oxygen is attached to the carbon atom, the oxygen is more electronegative, it is pulling the electrons, and carbon atom, it is getting the positive charge. In aldehyde, we have one alkyl group. This alkyl group, it is electron donating via plus I. Now, when it donates electron towards the carbon atom, this delta positive charge may be a bit lowered. But in the case of ketone, we have two alkyl groups. So this delta positive will be even lowered. And when there is not enough positive charge, the nucleophile will not automatically come and attack the carbon atom. Now, from both the perspectives, electronics and sterics, electronics matlab the presence or absence of electron. Here, the carbon atom should be electrophilic in the sense that it should have a larger delta or partial positive charge. That is happening in the case which is having larger positive charge, it is the aldehyde. And in the case of sterics also, we can see that aldehyde is not having any bulky group, and that is why the attack of nucleophile will be feasible. Now, in both the cases, we can see that aldehyde wins over ketone. Now, there are two reasons. Usko likh lenge. We'll write aldehydes are more reactive towards nucleophilic addition reaction, are more reactive, more reactive towards than ketone. Nucleophilic addition reaction than ketone. ठीक है? As aldehyde less hindered than ketone, as aldehyde is less hindered than ketone, and due to 2 plus I groups in ketone, aldehyde is more electrophilic. And in general, you can write reactivity of nucleophilic addition reaction. It is inversely proportional to number of alkyl groups. And let's suppose if there is a question that we have to compare CHO, propanone, and butane 2-one. Then in these three, we can say that the aldehyde will be the most reactive, followed by, here we have having two alkyl groups, and here we are having smaller alkyl group. That is why this will be more reactive. And then here we have a larger bulky group. That is why the butanone will be less reactive. So aldehyde and then ketones, and in ketones, what we have to see the number of alkyl groups. Jitna kam alkyl group hoga, so here you can see here we have only one alkyl group. Okay. Now here we have two alkyl group. Here also we have two alkyl groups. But this alkyl group is more bulky. That is why this is the least reactive. Krishna, we are done.
Yes, sir.
Now the first reaction that we are going to look is, please write here.
Go to your mother's phone. I need it.
Yeah, there.
Where?
First reaction is addition of ammonia and its derivatives. Okay, so we have carbonyl compound, aldehyde or ketone. We react this with ammonia, that is NH3. Now, this nitrogen atom, it attacks on the carbon atom like this. And this pi bond breaks. Now, there will be a reaction. This nitrogen atom will be attached on the carbon atom. And let us suppose these two groups are already present. यहाँ पे इसमें nitrogen, it is having 3 hydrogens. And it will get a positive charge because this nitrogen is forming it is giving electron density towards carbon atom. And this pi bond breaks, so the oxygen atom will get a negative charge like this. Now, if you look at the hydrogen atom here, this hydrogen atom will be having a highly delta positive charge because it is attached with more electronegative nitrogen atom. This nitrogen atom even has a positive charge. So this delta positive charge will be there in the hydrogen. Now this oxygen is having negative charge, so it can quickly attack the hydrogen atom like this. This nitrogen atom will give electron density to the positively charged. Sorry, this hydrogen atom will give the electron density towards the positively charged nitrogen atom. This will leads to the formation of carbon. The two groups are as it is. Here you will get nitrogen, and there are two hydrogens like this. And you will have here single bond O and single bond hydrogen. Now, this carbon atom, it is having a nitrogen and oxygen in the vicinity. So this oxygen atom, it still has a lone pair electron, and this hydrogen atom, it is still having a positive charge because it is attached with nitrogen atom. So proton transfer takes place very quickly. You know, this reaction, it happens very quickly because obviously whenever you have electron and positive charge, the electron will move towards positive charge. So it moves like this. This hydrogen atom, it gives electron density towards the carbon and nitrogen bond. After this, you can see that as soon as this oxygen atom, it is going to get a hydrogen atom, this will break its bond with the carbon atom. Okay, like this. Now, why it is breaking the bond with carbon atom? Because carbon and nitrogen is getting one more bond. Now, when carbon cannot form 5 bond, it will break one of the bonds. And the product that you are getting is carbon, double bond nitrogen, and this double bond nitrogen, it has only one hydrogen remaining. Plus, you have H2O. Okay, so the two hydrogens which were with nitrogen atom, it forms H2O with the oxygen of carbonyl compound. Now, even though this reaction is almost reversible, that the attack of oxygen atom on this hydrogen, but as soon as it forms water, which is a very stable compound, it is not going to go back. Okay, so forward direction में ही सारा का सारा reaction हो जाता because of the stability of water molecule. This is rather an unusual reaction because intermolecular reaction is happening. And after this, we are getting water, which is very stable. So if you are getting water as a product in any of the reaction, that reaction, it rarely go in the reverse direction. Okay, you get the forward reaction, that is formation of H2O. In general, what is happening, you can see, अगर हम reactant से लेके product तक जाएं, सीधा without looking at the steps, without looking at the mechanism, then what we are getting oxygen, plus you will have H2, and it's like this. Now, what is happening? You are getting the carbon with 2 bond as it is, the carbon with double bond as it is. Rather than oxygen, we have N, and this further bonded with hydrogen. Now, in general, if I see, we have carbonyl compound plus 2 hydrogens which are attached with nitrogen, and this nitrogen, let us suppose it has some group that is Z. So this oxygen of carbonyl and the 2 hydrogens of nitrogen compound, it will form water, and you will be remaining with carbon double bond nitrogen bonded with Z. ठीक है. Now we are going to look at, ये तो अमोनिया का हो गया ना, जहां पे आपको वाटर मिल रहा है और you are having NH. We are going to look at different ammonia derivatives and the products formed by the different ammonia derivatives. Write it down. Mir Arslan Krishnapriya, let me know once you're done.
Yes, sir, done.
Done, everyone? ठीक है. Now see, this is going to be a bit intense. I mean, there will be a few काफी reagents होंगे, आप तो ध्यान दीजिएगा जरा, है ना? And please try to understand the first few and then start writing once you have understood how to write the product. ठीक है? If you are having difficulty in writing the product in the first few, then please stop me. So I will be writing here reagent. You need to identify what is the Z. What is Z? Z, you have to identify nitrogen atom. It will be having 2 hydrogens. And whatever is attached to the nitrogen atom apart from 2 hydrogens will be the Z. ठीक है? 2 hydrogen के अलावा जो भी रहेगा वही Z है. And then I will be writing the product. First is NH3. ठीक है? So remove two hydrogens. What is remaining apart from nitrogen? क्या बचा बताइए जरा. If you remove two hydrogens, what is remaining? नाइट्रोजन में तीन चीज लगी हुई है ना. There are three hydrogens. If you remove two hydrogens, what is remaining? बोलिए
NH.
गाइस. नो, नाइट्रोजन को छोड़ दीजिए. सिर्फ क्या बचा आपके पास? हाइड्रोजन बचा. मेक सेंस? ठीक है. अब जब ये रिएक्ट करेगा कार्बोनिल कंपाउंड से, कार्बोनिल कंपाउंड में दो ग्रुप्स लगे रहेंगे, वो ऐसे ही डबल बॉन्ड रहेगा, वो ऐसे ही, और यहाँ पे क्या लग जाएगा? N के साथ H. ठीक है. तो इतना जो कार्बन और नाइट्रोजन यहां तक का जो पार्ट है ना, टिल हियर, दिस इज गोइंग टू बी द सेम. सब जगह ये रहेगा. दिस Z इज गोइंग टू चेंज. ये आपके पास अमोनिया है, and this is known as imine. Second is NH2, NH2. किसी भी नाइट्रोजन से आप दो हाइड्रोजन हटा दीजिए, आपके पास क्या बचेगा? NH2 बचेगा. यहां से यहां तक सेम, टू ग्रुप्स, डबल बॉन्ड N एज इट इज, बचा क्या आपके पास? NH2. दिस इज नोन एज हाइड्रोजीन. दिस इज नोन एज हाइड्रोजोन. थर्ड इज NH2, OH. NH2 हटा दीजिए आप, नाइट्रोजन और दो हाइड्रोजन हटा दीजिए, क्या बचा? OH. कार्बन, डबल बॉन्ड नाइट्रोजन, OH. This is known as hydroxylamine. And this is known as oxime. समझ में आ रहा नहीं आ रहा? अरसलान, कृष्णप्रिया, मीर.
Yes,
Yes,
sir.
sir.
ठीक है. फोर्थ में यू हैव NH2, NH, which is further attached with benzene ring. ठीक है. Now here what's going to happen? You remove the NH2, what is remaining? NH bonded to benzene ring. Benzene ring की जगह आप क्या लिख सकते हैं? C6H5. और you can also write PH. ठीक है. Now here the compound is going to be carbon, double bond nitrogen as it is. Then you will have NH, which is further bonded to benzene ring, that is also shown as PH. This is phenyl hydrazine. And this is phenyl hydrazone. Fifth is NH2. NH, NO2, and here also you have NO2. This is known as 2,4 dinitro phenyl hydrazine. इसका और एक नाम होता है, that is 2,4-DNP. 2,4-DNP. Remove the NH2, what is remaining? NH, NO2, NO2. And the product that you will be getting is carbon, double bond nitrogen, further bonded with NH, NO2 and NO2. This is known as 2,4 dinitro phenyl hydrazone. ठीक है. 2,4 dinitro phenyl hydrazone. Sixth one, C double bond O and NH2. ठीक है. So now here you remove this NH2 and you will get NH C double bond O NH2. ठीक है. These two hydrogens are not reactive, or rather this nitrogen also get not attached here. उसके एक सवाल आता है. We'll do that question also. This is what Z. So carbon, there are two groups as it is, double bond nitrogen as it is, further bonded with N, H, C double bond O NH2. This is semi carbazide. This is semi carbazone. Remove NH2, you'll get R, C double bond N, further bonded with R. This is also known as, this is Skiff's reagent. Skiff's base. बोलते हैं substituted amine. Then all of you, इनको ना एक
Yes.
बार प्लीज रिवाइज कीजिएगा, ठीक है ना. विल नॉट रिवाइज. देखिए, प्रोडक्ट बनाना बहुत ज्यादा हार्ड नहीं होगा आपके लिए, इफ यू अंडरस्टैंड व्हाट इज हैपनिंग हियर. ठीक है, कि आपके पास Z आइडेंटिफाई करना है आपको. C डबल बॉन्ड O N विल बी एज इट इज. उसके बाद फिर आपके पास जो Z है उसी को बस अटैच कर दीजिएगा. सो हाँ, एक और चीज जो आपके लिए इंपॉर्टेंट है हियर is the name of these molecules. So sometimes they will not give you the structure. They will rather give you what happens when propanone reacts with hydrazine, when what happens when hydroxylamine reacts with propanone, butane 2-one, like this. They can also give you these type of questions. So उसके लिए आपको structures पता होने चाहिए. Generally नहीं आते हैं ऐसे सवाल, but you have to prepare for the worst situations. Write a few remarks regarding this. These remarks are important है ना. ये remarks अगर आप याद रखेंगे तो free के marks आपके पास आ सकते हैं. बहुत ज्यादा आपको मेहनत नहीं करनी चाहिए. But and all of these remarks are also important. First is 2,4-DNP on reaction with aldehyde and ketone give yellow, orange or red PPT. ठीक है, and it can be used for the detection of aldehyde and ketones. ठीक है, so let us suppose we have a sample A और यहाँ पे आपने इसमें लगाया 2,4-DNP. It will give you yellow, orange or red PPT. ठीक है, and if this sample gives yellow, orange or red PPT, that means the sample is either aldehyde or it is ketone. Also, another question is regarding the semi-carbazide. In semi-carbazide, we have two NH2 groups. C double bond O NH2. ठीक है. Now you can see that this nitrogen atom, it is in resonance with the carbonyl carbon. ठीक है. Here also we have a nitrogen group, but this nitrogen atom, it has a lone pair which is available for what reacting. This nitrogen atom's lone pair, it is not available because it is showing what resonance. NH2, NH, double bond O, NH2. Sorry, not NH2, my bad. This will be NH2, and there will be a double bond here. This will be negatively charged, this will be positive charge. Okay. So since it is showing resonance, only this lone pair, it is available for the attack. You will write here like this. This NH2 reacts as the lone pair is localized. This NH2 group does not react due to delocalization of lone pair and resonance. Done, everyone?
Yes, sir.
Okay.
Yes, sir.
So that's it for today. And these two are very important points. इनको आप जरूर याद रखिएगा. And see, for the reactions, you will have to practice. ठीक है? Reactions के लिए, whatever we are doing, just redo those same reactions, and like 90% chances are कि आपके पास जो reactions आएंगे वो सारे notebook से ही. ठीक है? So you don't have to worry, but हाँ, आपकी जो notebook में जितने भी reactions हैं, उनके ऊपर अच्छी खासी कमांड होनी चाहिए. और वो हम ये भी नहीं कह रहे हैं दैट जनरल रिएक्शंस हमने लिखा दिया उसके हिसाब से आपके पास आएगा. ठीक है? फॉर एग्जांपल, इफ यू आर गोइंग टू गेट फॉर ओजोनोसिस ऑफ एल्कीन, तो ये जो एग्जांपल्स है ना, जिसमें मीथेनॉल बन रहा है, इथेनॉल बन रहा है, प्रोपेन 2 बन रहा है, मतलब यही सवाल में से इन्हीं में से कुछ ना कुछ आएगा. ठीक है? 90% ऑफ द चांसेस है इन्हीं में से कुछ ना कुछ आएगा. इफ यू आर टॉकिंग अबाउट हाइड्रेशन ऑफ एल्काइंस, then these 3 or 4 reactions that you have written, इन्हीं में से कुछ ना कुछ आएगा. ठीक है? So you don't have to worry about any other questions. जो आपके पास नोटबुक में उसी को प्रैक्टिस कर लीजिए. आप हाँ, इसकी को प्रैक्टिस कर लीजिएगा तो कुछ नया भी है तो भी आप कर सकते हैं. ठीक है? बट यू हैव टू प्रैक्टिस ऑल ऑफ दीज क्वेश्चंस. प्रैक्टिसिंग का मतलब क्या है? जस्ट रीड इट, एंड वंस यू हैव रीडन इट, देन बिफोर कमिंग टू द नेक्स्ट